Welcome back, all of you. In the previous lecture, we have seen the problem solving using Gauss-Seidel method. We have seen also some special cases, exceptional cases, where instead of load bus, if generator bus is given, what all are the steps to be followed, like that. Just refresh what all things we have done in the previous class. That is, if a question is asked in load flow analysis and if you are asked to solve it using Gauss-Seidel method or whatever method it may be, the first step is undoubtedly the calculation of bus admittance matrix. In that case, you should be very careful whether the given values are admittance or impedance. It should be first thing. It is the first thing to be noted. If the given values are impedance, then what should we do? We need to convert those impedance first to admittance. Then after that, you proceed with calculating the bus admittance matrix. That was the first step. Now in the second step is initialization of bus voltage that we have already discussed. Then before proceeding to the third step, you have to check whether the given buses are load bus or whether it is generator bus. If it is generator bus, then what will be there? Yes, the limit for reactive power would be given. So first you have to calculate the reactive power and you have to check whether your reactive power after calculation satisfies that limit. If the limit is satisfied, you can proceed further by treating the bus as generator bus itself. But if the limit is violated, you have to check which limit is violated, whether the upper limit violated or whether the lower limit violated. Depending upon the limit which is violated, you will be substituting your reactive power with the violated limit. And then you will proceed the problem by treating the bus as load bus. But please do remember, while treating the generator bus as load bus, the active power and reactive power value will be given the positive sign itself instead of negative sign. So, and we have seen some takeaway points also along with that problem. Okay. So once you are familiarized with all these steps and all these special cases, now you are ready to study in detail the flowchart of a Gauss-Seidel method. So it will be much more easy if you study the flowchart after thoroughly understanding the different steps. Okay, in that. So now we can, in this lecture, we will be discussing the algorithm and the flowchart for Gauss-Seidel method. Okay.
So before proceeding to the algorithm, let's move on to the flowchart of Gauss-Seidel method. So like any other flowcharts, it starts with this start. Okay, now while you get a question in Gauss-Seidel method, what is the first thing you do? You will read the question, right? And in the question itself, what all things mainly you read? Yes, you mainly read the total number of buses, isn't it? That first you will check how many buses are there in the power system given, or how many buses are there in the single line diagram given, whether it is 2, 3, 4 or 5, isn't it? So first you will read the bus. Then what all things you will read? You will read whether bus specification is given, and you will check whether bus admittance is given because you need to calculate admittance matrix, so you will check these things. Then what all things you will check? When the bus details are given, you will obviously check which all are the types of bus, whether it is load bus, whether it is generator bus, whether it is slack bus. That means you will be reading the active power, reactive power for generator buses, and you will be reading this the specified voltage for this generator bus. Whereas for the load bus, you will be reading the actual power as well, active power as well as the reactive power. Now, if it is a generator bus, you will obviously search for the limits of the reactive power, isn't it? So, maximum value as well as the minimum value. And this way, you remember. What will you observe when a question in Gauss-Seidel method is given to you? So, that is our first step. Read the number of buses. Then you will check the admittance value. Then you will read the buses, whether active power given, reactive power given, specified voltage is given, whether limits are given. Okay, that means with this you have completed reading the question. So what's the next thing you do? That is, you will obviously calculate the admittance matrix Y bus. So that is a second case, a second stage. You'll be calculating the bus admittance matrix. Now, after calculating bus admittance matrix, what was the next step? Yes, initialization of bus voltage, isn't it? Now the next step is this, initialization of bus voltage. Again, reminding you, how will we initialize bus voltage? We will be initializing bus voltage with the magnitude as 1 and angle as 0. Okay. Now, if a generator bus is given, how will you initialize the bus voltage? Whether we will give the magnitude as 1? No, we will give the magnitude as the magnitude specified in the question. Okay. Now, one more thing here is, we need to set a convergence criterion called by the name epsilon. Okay. Convergence criterion epsilon. What is this epsilon? Okay, now for that I'll make you much more clear to it. Consider what does this notation indicate? This notation indicates voltage of the second bus after first iteration. This indicates voltage of the second bus after second iteration. This indicates voltage of the second bus after third iteration. So in all the three cases we are calculating voltage of the second bus itself. Okay, example. After first iteration, assume that you got the voltage of the second bus as 1.02. Okay, you are not satisfied this voltage and you proceed for the second iteration. After the second iteration, you got the value like 1.029. You compare these two values. There is a minor difference of voltage in the first iteration as well as in the second iteration, right? So we can see that your voltage became much more accurate in the second iteration. Again, still you are not satisfied with the result. So what did you do? You proceed to the next iteration, that is the third iteration. And you got the voltage value like this, 1.0289. Now you compare these two. You can say the value after third iteration is much more accurate, isn't it? Now, as long as how far iterations you do, if you are performing n thousand iterations or 10,000 iterations or whatever may be the number of iterations you perform, your voltage will become much more and more accurate. It may be accurate after 1 2 3 4 5 6 7 8 9 10 after decimal places, like that. So practically we don't need this much iteration, right? So if you how will you judge whether you can stop the iteration or not? For that, we are introducing a convergence criterion, that is epsilon. So you'll be setting a convergence criterion epsilon. For example, you have set the convergence criterion as 0.001, which means the difference between two consecutive iteration value should be less than this convergence criterion. If that is satisfied, you can stop the iteration. What does this mean? If I am setting it as 0.001 and in the next iteration I got the value as 2890, something like that. We can say that after the fourth iteration, while you take the difference in the voltages in the third iteration and fourth iteration, you will be getting it as 0.000, again one more 0, and something like that, isn't it? So that means the difference between two consecutive iterations is now less than your set convergence value, which indicates you can stop the iteration right here. If this condition is not satisfied, you will proceed this iteration by increasing the count of k is equal to 1. So why are we setting a convergence criterion? Because if we do not set any convergence criterion, we will go on doing this iteration and the infinite number of times. Okay, so at some point of time we need to stop the iteration. For that we are using this convergence criterion epsilon. I hope this is clear to you. So that was it. So we will be setting, coming back, we'll be setting the voltage as 1 plus J0 and we'll be setting the convergence criterion as epsilon. Okay, and you're going to start the first iteration, which means your iteration count k should be equal to 0. Okay, so you can remember these stages for this flowchart, right? Just compare with how you proceed solving problem manually. Okay, so after that you move to your first bus. Okay. When you move to the first bus, what will you check? You will check whether the bus is slack bus, whether the bus is generator bus, or whether this bus is load bus. So that's it here. You're checking whether the bus is slack bus. Obviously, the first bus was slack bus in all our previous problems. So we can proceed with that problem itself. So you checked for the first bus, it was slack bus. So if it is a slack bus, do we need to calculate voltage or voltage magnitude or voltage angle? No, because it is already specified. No need to calculate voltage magnitude or voltage angle. So what should we do? We need to simply proceed to the next bus, isn't it? So in order to proceed for the next bus, your bus count P should be equal to 2, isn't it? So let's see, is there some other command like that? So you found that it is a slack bus. So you are going to move in this direction. So you are moving downwards. Yes, you reached here. What is there here? No, you are not doing anything. You are simply setting the bus count is equal to P plus 1. Now here your bus count become equal to 2. Okay. Still, you need a terminating criterion. You have to check whether your new bus number is greater than the total number of bus. Here, for example, for our question, let the total number of bus n is equal to, let the total number of bus be equal to 4. Okay, so we have reached now the value of p is equal to 2. Okay, 2 is the 2 greater than 4? No, 2 is not greater than 4. So you'll be coming back here. You'll be coming back here. Now the bus count is 2 and you are checking whether it is slack bus. No, it is not slack bus. Then what will you do? Then you will check whether it is generator bus. You found that the second bus was not generator bus. So what could be the second bus? It is not slack bus, it is not generator bus. So what could be your second bus? Yes, your second bus is load bus or PQ bus. So what should we do if you get a PQ bus? Yes, once you get a PQ bus, comes here. Okay, once you get a PQ bus, you'll be calculating the voltage. Okay, that is Vp raised to k plus 1 you will be calculating, and you will be calculating the accurate value also when the alpha is given. Okay, isn't it? So then you will be moving to the next step here where you will be calculating delta Vp. Delta Vp simply means the difference in the voltage of the present iteration and the previous iteration. Okay, you're simply checking whether the difference is gonna be less than your set criterion. For that you're just calculating the delta. Okay, then you'll be setting the assumed value is now become equal to your calculated value because you have initially assumed the voltage as 1 plus J0. Now you have some calculated value of voltage. You'll be setting that voltage. Then after that, what should you do? You should increase your bus count because your analysis of the second bus is now over. Now you are going to increase the bus count. P is equal to P plus 1. Now it is equal to 3. Let that it be equal to 3. Is the 3 greater than 4? No, it is again no. So now again moving back to the initial condition, again you are checking for slack bus, and if it is not a slack bus you are again checking for whether it is generator bus. Again you found that it is not a generator bus, and obviously it is a load bus. Then the same process repeats. Okay, and again coming back here, increasing the bus count. Now your bus count become 4. So is a 4 greater than 4? No, your 4 is not greater than 4. Again coming back here, you check whether it is slack bus. No. You check whether it is generator bus. If it is a generator bus, I am moving downwards. If it is a generator bus, what would you do? You'll be temporarily setting a magnitude, isn't it? You don't have the value, you have only the specified value of voltage. You do not have the angle. Then what would you do? You would calculate the reactive power. Remember? After calculating the reactive power, what was the next step? You will check with the limit, whether the limit is less than your lower limit or whether your reactive power is greater than the upper limit. You will be checking with the limit. If the limit is violated, what will you do? You will treat the bus as load bus. Here also, if the other limit is violated, what will you do? You will treat this bus as again load bus. In both these cases, if you are treating the bus as load bus, then the further analysis will be same as that we have done earlier with the load bus. Clear? Now, if these two limits are satisfied, then what will we do? You will be treating the bus as generator bus and you will be calculating the angle. Okay, you will be calculating. After this is done, what will you do? Again, you'll be calculating the difference in the voltage. You'll be setting the voltage. Again, here the bus count become equal to 5. Now you'll be checking whether 5 is greater than 4. Yes, 5 is now greater than 4. So you will not be moving this path. You will be moving this path because you have met that terminating criterion. Okay. And what will you check? You will check the difference in the voltage. Okay. Of the difference in the voltage. And if the difference in the voltage is less than epsilon, what is there? If the difference in the voltage of two consecutive iterations is less than the convergence criterion epsilon, you can stop the process, isn't it? So while stopping, you will be calculating the line flow, that is the current as well as the slack bus line flow means other bus powers or current as well as the slack bus power, and you'll be stopping it. Now the question is, if this criterion is not met, what should be done? Yes, if the criterion is not met, what should be done? You have to perform the next iteration. So in order to perform the next iteration, what should be increased? The iteration count k should be increased. K should be is equal to k plus 1. After that, you should directly move to our first step. From here onwards, you need to start again. Okay, until that particular criterion is met. Okay. So I hope this is clear to you and this is easy for you to understand once you try to solve all the problems in Gauss-Seidel method. Do not directly start studying from the flowchart. It will be quite difficult for you to understand the examination point of view. So you first try to solve as much problems in Gauss-Seidel methods by referring to our previous lectures and then you come back to this algorithm and the flowchart. Am I clear? Okay, so this was the flowchart and the basic concept is that you just think what will you do once you get a question in Gauss-Seidel method. By analyzing in that aspect, it would be easy for you to understand this flowchart. Now, all the steps in the flowchart written in the sentence form will be your algorithm or the steps. So first you proceed with the flowchart, then you try to write the steps. So I can say that your step will be like this. It would be easy. Procedure for load flow analysis or rather the steps or the algorithm. Okay. Assume a flat voltage profile. What do you mean by flat voltage profile? It simply means 1 plus J0. Generalizing for all except for generator bus. Okay, then what you said? You will set an epsilon and it is called our convergence criterion. See, these steps we already discussed in our flowchart. So once you are thorough with the flowchart, you can write that flowchart in the sentence form and that would be your algorithm or your steps for calculating this. See, and if at some point of time here what is there is that the calculation equation is also included along with that. In the flowchart we have mentioned you have to calculate the reactive power. So in the steps it is the equation for calculating that particular reactive power is also included. That is the only difference. So if you are running out of time in examination, you need not write this equation. Instead you write the steps associated with it. Okay, if both algorithm and flowchart are asked together and if only steps are asked, you are supposed to write in detail about each things using like that. Okay, so like that we are proceeding with different steps. This you can easily understand once you get from the flowchart. Okay, so here is it, your algorithm and your flowchart. So once again, I am repeating, once you are familiarized with the steps in Gauss-Seidel method, you try to write down those steps in a pictorial representation. It would become your flowchart. And if you find any confusion or lack in clarity in this explanation, please feel free to contact me through mail or message or the comment in the comment box. Okay? Thank you.